Welcome. In this video, we are going to take a look at problem 15. It is from chapter 25 of College Physics 2E by OpenStax. We have a ray of light going from air through crown glass and then into water. We need to calculate the amount the ray is displaced. We're given that the incident angle, that is theta 1, is 40.0 degrees, and that the glass is 1.00 centimeters thick. All right, so N1 is for air, and let me just add that in. The index of refraction for air is 1.0. The middle layer is the crown glass. If we look up the index of refraction, we will see it is 1.52. And then the layer with N3 is the water. And the index of refraction N3 is 1.333 for water. And then we also know that this bluish layer is 1.0 centimeters thick. All right, let's take a look at what happens at the first interface. That is between air and glass. We can use the law of refraction. And so N1 sine theta 1 is equal to N2 times sine theta 2. Solve this for sine theta 2. And we get N1 sine theta 1 divided by N2. Now all we have to do is take the sine inverse of both sides, and we get theta 2 is the sine inverse of N1 sine theta 1 divided by N2. Okay. Substituting the values, we get 1 times the sine of 40.0 degrees divided by 1.52. I did the calculation and I got theta 2 is 25.0 degrees. Now we can take a look at what happens at the second interface. And I'll just put that over here. We use Snell's law, or also the law of refraction. This time it is N2 sine theta 2 is equal to N3 sine theta 3. And this time we want to solve for sine theta 3. We get N2 sine theta 2 over N3. Take the sine inverse of both sides. So we have the sine inverse of N2 times sine theta 2 over N3. Substituting the values, we have 1.52 times the sine of the theta 2, which is the angle we just found, 25.0 degrees, divided by N3, which is 1.333. I did this calculation and I got theta 3 is 28.2 degrees. Okay, so now we need to find that delta x. And so we can think of it this way. If we drop this original normal down, then we can consider this little bit to be an x2, and then keep this going down, and we'll keep this going down. This is x1. This is the delta x. Okay. So we'll draw the theta 2 triangle. It's our theta 2. This side is 1 centimeter. This side is x2. We take the tan of theta 2. We get the opposite, x2 divided by the 1.0 centimeters. Okay, so x2 is 1.0 centimeters times the tangent of theta 2. x2, 1.0 centimeters times the tan of 25 degrees, and x2 is 0.467 centimeters. Okay, there's our x2. All right. Now we'll go for x1. Okay. And so this will be a theta 1 triangle. We still have our 1 centimeter. And now we have x1. Right, you can think of the interface as right here. And there's where our theta 1 goes in. Okay, so now the tangent of theta 1 is going to be the x1 over the 1 centimeter. So x1 is 1 centimeter times the tangent of theta 1. So x1 is the 1 centimeter times the tangent of the 40 degrees. x1 is 0.839 centimeters. Okay, so now our delta x is going to be the x1 minus the x2. And that's because x1 goes the whole way and x2 goes a shorter distance. So we have 0.839 centimeters minus 0.467 centimeters. And we find that delta x is 0.372 centimeters. I hope you found that helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.